Hey guys, so back with another like 5-minute quick video here. While the other video loads, I did stop at 9 minutes of the other video because you couldn't really see my hand. So this is a resketch of what I just drew. This is everything that was on the last piece of paper, so to speak, everything I just drew. One thing that I did want to highlight really quickly is I didn't talk about who could believe in this type of time. So we talk about the Mayans believing in a time of spiral, a 3D spiral, people here. It's not 2D. We'll talk about the 3D here in a second. So the Kali Yuga believes that we're going from a basically high point on a slow degradation, or however fast degradation, a couple thousand years degradation, a few thousand years, like 23 or something like that. And then we slowly go back up, right? Mayans are more or less like, we're here, we're at so-called starting point of evolution when everybody's happy, our happy point, and then we're not, and then we are, and then we're not. You know, it's a different type of depiction. But it could also be seen this way for the Kali Yuga. We're going on a high rise, then we're going back on a slow backdrop, then we're coming back up and back on a slow backdrop. This could be considered the dark shadow side. This could be considered dark matter. It could be considered a parallel universe. However, it's all part of the same exact spiral. So it's kind of where, well, the same exact Mobius. Kind of where the, sorry, I have to kind of watch out for coyotes where I'm at. I'm outside. I know they're cute, but I would never come up to a coyote that close. So back to where our grid of 90 degrees, well, we actually didn't get into this, where our triangles come in. And if you're taking some trigonometry, geometry, it's kind of like 4 triangles. It is 4 triangles. These are just totally not equal triangles. But you start to understand why angles are cool and why they can be used to create, mechanical pencil, create a derivative, so to speak. So you can derive one point from another point using, let's just say the angle is here. Not there, actually. That's not where I want it. What about, it's gonna be, well, you can make it wherever you want to. It's your graph, right? You would be able to put this into a computer program. You would be able to make it wherever you want. There's a triangle. There's a triangle. Let's say there's also a couple triangles over here. There's a few over here. There's one over here. And the only thing that I'm missing from this graph that I didn't have on the other one was the identification point. So now we have our A. This is probably better, this one. A minus, let's start here. This is A minus 1, 2, 3, 4. Yeah, so I'll go A minus 4. A minus 5. A minus 6. A minus 7. A minus 5. If you have drawn this, like I said you should in the beginning, you have drawn a fractal. You should congratulate yourselves. You've just done a fractal, and not only have you done a fractal, if you wrote the numbers too, you actually wrote the function. So the function, the f of, I don't know why I wrote that, the function of x, aka at this point, the function of a, right, is equal to a minus 5. Look at you! Can you believe it? You actually can do calculus. You just lucky to calculus, bro. All you need to know is a chain law, and all the chain law is gonna do is just show you how to go like that down in a sequence. You did that, bro. You did that. If you drew that, you did that. If you tried to follow along with it, you just did calculus. Congratulations. So I only got about another minute that I could record on this video, and then we'll go ahead and get to the third part. I think it'll be the third and final part here. But yeah, let's just go ahead and do a recap. You got your Mayan spiral time. You got some linear depiction of measurement, and you also have a secular. a more of a cycle type of orbital, potentially. This part, excuse me, we haven't quite got there, but in this depiction, this would be our sun. It would be also any other point that you would like to. This could be anything easily. But I'll see you here in a second. Okay, good job, guys.